Hi, I'm Vivian live from the University of Colorado Boulder, and the title of our paper is Human-AI Collaboration via Conditional Delegation, a Case Study of Content Moderation. This is a joint work with Samuel Carton, Rajat Bhatnagar, Vera Liao, Yunfeng Zhang, and Chenhao. AI has achieved impressive performance in many tasks. For example, Google's AlphaGo beat the strongest Go player in the world, Lee Sedol, in 2016. However, it can still fail terribly because they are not always trustworthy. In the case of autonomous driving, it has led to some horrible accidents. In this paper, we asked the following question: how can imperfect models be used effectively in collaboration with humans? Prior work has focused on AI assistants such as explanations and predictions to determine every decision. However, this is not feasible and not scalable for some tasks where the large number of decisions is a key challenge. A good example is content moderation, where moderators decide on individual comments for further actions. In this paper, we use Reddit as a testbed to assist humans on making decisions with an imperfect model. Normally, Reddit moderators use a tool called Auto Moderator, with which they manually customize a rule-based system to automatically identify comments for deleting or reporting for further review. However, this approach misses out on the benefit of AI, especially since rigid rules often do not work on informal languages such as social media posts. For example, while there are toxic comments that contain curse words, there are also non-toxic comments that contain curse words as well. In this work, we propose an alternative paradigm of human-AI collaboration, conditional delegation. The goal is to strike a balance between full automation and manual approaches by allowing humans to identify trustworthy regions. At first, human and AI work together to identify trustworthy regions of AI before deployment. In other words, model decisions are reliable or trustworthy for examples within these regions. Once deployed, the AI model only affects decisions for instances in the trustworthy regions. For the remaining decisions, another set of actions can be taken, such as manual review or employing a different model, since the given AI's decision on them cannot be trusted. Conditional delegation employs a greater level of automation than human-AI collaboration on every single decision. It also provides humans with active control on when to use an AI model and in what ways. Now let's take a look at the different types of interfaces we use during the user study. We develop novel interfaces to assist humans in creating rules. In the manual condition, there is no AI involved, and all comments matching human-created rules will be considered toxic. Conditional delegation is included in the remaining conditions. What that means is that created rules are considered trustworthy regions of model, and any comments containing these words that are predicted as toxic will be considered as a toxic comment. In the predicted label condition, users are shown the comments' predicted labels. For ease of use, they are also able to search and filter by the predicted labels. In this condition, not only users are shown predicted labels, local explanations, which are words that the model uses to determine whether a comment is toxic or non-toxic, are shown to the participants. And in the final condition, users are also shown global explanations, which are a list of words the model uses in determining comment toxicity when assessing the entire dataset. Now let's take a look at the measures that we use in this experiment. Our main goal is to examine whether humans can improve the precision of the model with a good coverage via conditional delegation. We use average precision, which reflects the average quality of every single rule a person provides. Another measure, reward, measures the quantity difference between reported toxic comments, also true positives, and reported non-toxic comments, also false positives. As such, this measure reflects both precision and coverage. To measure efficiency, we use rules per minute. Rules per minute is the number of rules added divided by the total time spent by the participant. Lastly, we use number of actions to measure engagement. There are a total of 13 unique actions, and we consider the number of logged actions a participant took during the experiment task. Now let's take a look at the user study results. We find that users are able to create rules with higher precision than the model working alone. As long as predicted labels are provided, people can easily identify rules with high average precision and with high coverage, as reflected by rewards on this slide. Recall that rewards measures the quantity difference between reported toxic comments and non-toxic comments, which reflects precision and coverage. Through conditional delegation, we show that elusive complementary performance is achieved, meaning that human plus AI performance exceeds human alone performance and AI alone performance. When it comes to efficiency, predicted labels only lead to the lowest number of rules per condition. However, with the help of explanations, humans are able to achieve a greater number of rules per minute. In other words, global explanations help participants to achieve the highest efficiency to create rules. To understand this improvement in efficiency, we examine the overlap between human-created rules and the most frequent words in global explanations. Global explanations lead to much higher overlap than the other conditions. This observation confirms that global explanations provide direct hints for possible rules, thus improved the efficiency to create required number of rules. Lastly, we find that users with all delegation support features were also much more engaged as compared to the manual condition. In particular, predicted labels only condition incurred many more actions than other conditions. In summary, we propose conditional delegation as an alternative paradigm that allows users to create trustworthy regions when imperfect models are used. Using content moderation as a testbed, conditional delegation achieves complementary performance, improves task efficiency, and increases engagement.